All right, let's look at the method of undetermined coefficients. Here's an example. Use method of undetermined coefficients to find a particular solution y sub p of this following non-homogeneous differential equation. All right. So before we find a particular solution y sub p, we need to find the complementary solution, right? So complementary solution is the solution of the homogeneous version of the equation. So we're going to turn the original equation into a homogeneous equation by turning the right-hand side into 0, right? So once you've done that, all you have to do is do the characteristic equation. So find the characteristic equation, which is r squared minus r minus 6 equals 0. And this is a simple quadratic equation, so we can solve it by factoring it out, right? Then we found that the r is going to be equal to -2 and +3. Right? So we have two distinct real roots. So we know that the solution, complementary solution, is going to have two linearly independent exponential solutions, which is one is e to the -2x, and the other one is e to the 3x. Right? So once we found the complementary solution, we can work on a particular solution. Right, so we're going to pay attention to the right hand side here, e to the 2x, right? So we're going to list all possible derivatives of e to the 2x, right? We kind of got lucky here because all the derivatives of e to the 2x is going to be e to the 2x. So we only have one possible term, so it's which is e to the 2x. So we can write the initial guess as y sub p is equal to some constant a times e to the 2x, right? Then before we keep going, we have to make sure that there is no overlap between the particular solution and a complementary solution. In this case, there is none, so there's nothing else to do. But if there were an overlap, we would have to keep multiplying the form of the particular solution by x until there is no overlap anymore, right? But in this case, we can do that. So a is the only undetermined coefficients. So all we have to do is basically plug this guy back into the original differential equation so that we can find the value of a, right? So let's do that. So we need the first derivative and the second derivative. So by taking the first derivative, we got 2a e to the 2x, right? We can take another derivative to get 4a e to the 2x, right? So we plug all these guys back into the left-hand side of the equation. We're going to get this, right? Plug it all in. Right, and you can just combine all three terms together. I believe it's going to add up to -4a e to the 2x, right? Then we have to make sure that this is going to match the right-hand side, which is e to the 2x. So we're going to set that equal to e to the 2x, right? By comparing the coefficient between these two guys, -4a and a 1, so we know that the -4a is going to be equal to 1. Right, then we can simply divide both sides of the equation by -4. We can get the value of a, which is -1/4. All right, so we can just put this a value back into this form. We have the particular solution, which comes out to be y sub p is equal to -e to the 2x over 4. Right? That's it. I hope that this was clear.